One patent, filed quietly. No press conference, no state media fanfare, no nationalistic headline about China beating America at semiconductors. Just a filing number, a university affiliation, and a technical claim that, if it holds, means the most carefully constructed piece of America's chip containment strategy has a problem it didn't account for. The lab is affiliated with a Chinese university that has been on the U.S. entity list since 2020, which means it was cut off from American equipment, American software, American technical collaboration. The sanctions were supposed to freeze its capabilities in place. Instead, it spent 4 years doing something more dangerous than trying to buy what it was denied. It built a replica of the system used to verify that chips actually work. Let that sit for a second. Not the chips, the testing stack. Most coverage of U.S.-China semiconductor competition focuses on the obvious choke points: ASML's EUV machines, TSMC's leading-edge nodes, NVIDIA's H100s. Those are the weapons. What almost nobody talks about is the instrumentation layer that sits beneath all of it. The equipment and software used to stress test, validate, and characterize chips before they ever go into a product. Electronic design automation tools, test vector generation, parametric analysis benches. This is the infrastructure that tells you whether a chip works, why it failed, and how to fix the design. It is also, almost entirely, American. Synopsys, Cadence, Keysight, Teradyne. The export controls that hit China in October 2022 and expanded through 2023 weren't only about blocking advanced fabs. They were about denying China the ability to know whether what it built was good. You can make a chip. You cannot easily make the tools that tell you if the chip is any good. That was the logic, and it was sound logic, for a while. The Harbin Institute of Technology, one of the 7 Sons of Heaven universities China's military-industrial complex draws from most heavily, did not respond to the entity list designation by slowing down. According to patent filings tracked by analysts at Georgetown's Center for Security and Emerging Technology, its semiconductor research output increased after 2020. The lab in question published work on parametric test methodology in 2022, a follow-on paper on signal integrity benchmarking in 2023, and now a patent on a core component of what amounts to a domestically built chip characterization environment. One patent does not equal a full EDA stack. I want to be precise about that. This isn't a China solved the chip war moment. But here's what it is: proof of concept. Evidence that the containment logic had a blind spot. The assumption was that testing infrastructure was too complex, too interdependent, too deeply embedded in decades of American toolchain development to be reverse engineered or rebuilt from first principles in any reasonable time frame. A university lab, not SMIC, not Huawei, not a billion-dollar state enterprise, just filed a patent that starts to answer the question of how wrong that assumption was. I'll tell you what's in that patent in a moment, but first, the reason this particular lab matters, and why the timing is not a coincidence. Harbin Institute of Technology sits in China's northeast, close enough to the Russian border that in winter the temperature drops to levels that make outdoor electronics testing genuinely impractical. It is not, geographically or culturally, the obvious center of China's semiconductor ambitions. That distinction usually goes to institutions in Beijing, Shanghai, Shenzhen, the corridor where money, talent, and state attention concentrate. Which is exactly why what happened in Harbin is worth paying attention to. When the entity list designation landed in 2020, HIT lost access to something most Western analysts underestimated: not just equipment, but collaboration networks. The informal technical exchange that happens at IEEE conferences, in joint research agreements, in the quiet back channel where a PhD student emails a professor at MIT about a measurement anomaly and gets a useful reply. That texture of knowledge transfer, the stuff that doesn't show up in export control filings, went dark. What HIT did next follows a pattern China's defense-linked universities have refined over decades, but rarely this visibly. They turned inward and got specific. Rather than trying to reconstruct the entire American EDA ecosystem, which would be like trying to rebuild a rainforest by planting individual seeds, the lab identified the thinnest, most load-bearing beam in the structure. Parametric test coverage. The process by which engineers determine whether a fabricated chip's electrical characteristics fall within the tolerances required for it to function reliably under real operating conditions. This sounds narrow. It is narrow. That's the point. The specific patent, publication number CN1179299956A, filed through HIT's Integrated Circuit Research Division, describes a methodology for automated test vector generation combined with a signal characterization framework that doesn't depend on synapses or cadence toolchains. The underlying approach pulls from work the lab published openly between 2021 and 2023, which means the patent isn't a surprise if you were reading their output. Most people weren't. What the patent claims, in technical terms, is a way to generate the input stimuli used to probe chip behavior, and then analyze the output signatures, without the proprietary libraries that American EDA tools use as their core reference architecture. Independent verification, built from academic literature, open-source toolchain fragments, and what appears to be significant original work on the signal integrity modeling side. Now, the counterargument, because it deserves a real hearing. Several serious analysts, including work published through CSIS, have argued that indigenizing one component of a testing stack does not constitute a functional alternative. EDA tools are not modular in the way that, say, consumer software is. Synopsys Fusion Compiler doesn't just provide one function. It provides thousands of interdependent functions that have been co-developed with foundry process design kits over decades. You cannot swap one piece and keep everything else. The ecosystem is the product. That's true. And it's also how every disruption in technical infrastructure has ever started. The transistor wasn't invented to replace vacuum tubes in every application simultaneously. GPS didn't replace navigation charts on day one. The question isn't whether CN1179299956A replaces Keysight's test benches tomorrow. The question is whether it demonstrates that the underlying logic, China cannot build this because it is too complex and too interdependent, is holding. There's a specific detail buried in the patent's cited references that I keep coming back to. 3 of the papers it cites are from American universities, published openly, accessible to anyone. The foundational work that American EDA companies built their proprietary tools on top of, the academic layer beneath the commercial layer, was never restricted. It couldn't be. It was peer-reviewed research, published in IEEE journals, meant to be read. HIT read it, carefully, for years. And that brings us to the part of this story that makes the testing stack vulnerability look like the smaller problem. There is a version of this story where the United States saw this coming. In 2022, the Commerce Department's Bureau of Industry and Security published an expanded foreign direct product rule that covered not just semiconductor manufacturing equipment, but certain categories of design software. The controls were specific, detailed, and, on paper, comprehensive. Cadence and Synopsys were required to cut off Chinese customers above defined capability thresholds. Keysight stopped servicing certain accounts. The perimeter looked solid. What the controls couldn't touch was the thing HIT actually used. Public academic literature, open-source toolchain components, specifically elements of the Open Road project, a DARPA-funded initiative to democratize chip design tooling that has been freely available since 2018, and the institutional knowledge accumulated by Chinese researchers who trained at American universities before 2020, published their work in American journals, and then returned home. DARPA funded the open-source tools that partially enabled the workaround to DARPA-adjacent export controls. I'm not going to call that ironic because the word doesn't carry enough weight. It's more like a structural contradiction that nobody resolved because resolving it would have required restricting American academic publishing, which nobody was willing to do for good reasons, but the gap existed, and Beijing walked through it. Here is where I want to push back on my own argument slightly, because intellectual honesty requires it. The leap from one parametric testing patent to a functional, fab-integrated chip verification environment is not trivial. The companies that built American EDA dominance, Synopsys was founded in 1986, Cadence in 1988, spent 30 years accumulating process design kit integrations, foundry partnerships, and bug fixes for failure modes that only appear at scale. CN 1179-29956. A describes a methodology. Methodology and working infrastructure are separated by an enormous amount of engineering pain. Chinese fabs, particularly SMIC, operating under its own set of restrictions, would need to validate any new testing approach against real silicon across hundreds of process corners before trusting it. That validation process takes time, probably years, possibly a decade for full-stack equivalence. But here's the reversal, the thing that reframes the timeline question entirely. China doesn't need full-stack equivalence. It needs sufficiency. Specifically, it needs testing infrastructure good enough to support the process nodes it can actually fabricate right now. SMIC's N+2 node, roughly equivalent to an early 7-nanometer process, does not require the same verification depth as TSMC's 3 nanometers. The complexity of the testing problem scales with the complexity of the chip. And if HIT's framework can adequately characterize silicon at the nodes China currently manufactures, then the containment logic fails at exactly the level where China's near-term military and industrial requirements live. This is the number that matters, and it doesn't appear in most coverage of this patent. The People's Liberation Army's current modernization roadmap, outlined in the 2023 edition of the Pentagon's annual China Military Power Report, does not require leading-edge consumer chips. It requires reliable, verifiable, domestically tested chips for radar systems, missile guidance, encrypted communications, and autonomous vehicle control. Those applications run on mature nodes. Mature nodes are exactly where a partial, first-generation domestic testing stack could be sufficient. The patent isn't aimed at competing with Apple's Silicon team. It's aimed at making China's defense electronics supply chain auditable without American tools in the loop. One more specific detail. The lead researcher on the patent, I'm not going to name them here because I don't think individual researchers are the story, completed a postdoctoral fellowship at a U.S. national laboratory before the entity list designation. The techniques described in the patent's core claims show clear intellectual continuity with work published during that fellowship period. That work was published openly. It was good work. It was meant to advance the field. It did. So where does this actually leave us? The export control architecture the United States built between 2019 and 2023 was the most aggressive use of technology denial as strategic policy since COCOM, the Cold War-era coordinating committee that restricted technology exports to Soviet bloc countries for 4 decades. The Biden administration's October 2022 rules in particular represented something genuinely new. An attempt to use America's chokehold on semiconductor tooling, not just to slow a competitor, but to freeze an entire technological trajectory in place. Ambitious, arguably necessary, and built on an assumption that is now visibly under pressure. The assumption was that complexity is a moat, that the interdependence of the American semiconductor ecosystem, the way Synopsys talks to TSMC's PDKs, talks to ASML's process parameters, talks to Keysight's test benches, was so deeply entangled that no isolated actor could replicate meaningful pieces of it within a policy-relevant timeframe. HIT's patent doesn't demolish that assumption, but it introduces a crack in the specific wall that was supposed to be the hardest to climb, the verification and testing layer, and it does so from a sanctioned university using publicly available academic literature in under 4 years. My read on this, and I'll stake something on it. The United States is going to discover over the next 3 to 5 years that the export control strategy worked exactly as designed at the leading edge and is eroding faster than expected at the mature node level. SMIC will not produce 2-nanometer chips in 2027. That part of the containment holds. But China's ability to independently verify and characterize chips at the 7 nanometers to 28 nanometers range, the range that covers most defense electronics, most automotive applications, most industrial control systems, will be meaningfully less dependent on American tooling by 2028 than it is today. The gap will not close. It will narrow in the specific places that matter for near-term strategic competition. That is a different outcome than either side is currently advertising. What should the U.S. actually do with this information? The honest answer is that the academic literature problem has no clean solution. You cannot restrict IEEE publications without dismantling the research ecosystem that produces American semiconductor leadership in the first place. The pipeline that trained the HIT researcher who wrote this patent also trained the engineers at Intel, Apple, and Qualcomm, who are keeping America ahead. Closing it to stop Beijing means closing it to yourself. What you can do, and what the Commerce Department has been slow to operationalize, is build a much faster early warning system for exactly this kind of incremental capability development. One patent from one lab is a data point. A cluster of related publications from 5 entity list institutions over 18 months is a signal. The intelligence community tracks Chinese missile telemetry in near real time. It does not have an equivalent system for tracking the quiet accumulation of technical capability in university labs. That asymmetry is going to cost something, eventually. Here's what I keep returning to. The thing that makes this story genuinely uncomfortable isn't that China is cheating or stealing or doing something illegitimate. The HIT researchers cited their sources. They published their intermediate work. They filed a patent through normal channels. They did, in other words, exactly what the academic system is designed to encourage. The uncomfortable part is that America built an open system optimized for producing knowledge, and then tried to use a closed system optimized for denying it. Those two things are in tension at a level that export control regulations cannot fully resolve. A university lab in Harbin, working in the cold, reading the literature, just made that tension visible. If you've made it this far and you're thinking about this differently than when you started, share it with one person who'd push back on it. That conversation is more useful than the algorithm.